Okay, so today we are talking about linear models and scatter plots. So, scatter plots are a collection of points, and they are said to have a correlation if they trend in the same direction. If the y value increases as the y value increases, it says that they have a positive correlation, so like a positive slope. If the y value decreases as the x value increases, they have a negative correlation. And then if it's just totally random, they have no correlation. Okay. So number 1 tells me on a Friday night, 22 students in a class were asked to record the number of hours they spent studying for a test on Monday. This teacher sounds terrible. And the results are shown below. The first coordinate is the number of hours, and the second coordinate is the score on the test. So, yeah. What? The kid who studied for 10 hours got a 98.
Yeah, no, but somebody studied for literally like, who studied for 3 hours and just got a 49.
Maybe they were lying to make the teacher think that they were, you know, working.
How many people study for 10 hours? How do you even that? Okay. How do you even study for that? You just do math problems over and over.
Yeah.
Remember what you need to know and then you're studying.
Okay, so what's going on the bottom here? Hours spent studying. Okay, and then what goes over here? Okay, so what do you want me to label my hours like?
It's for my second period.
It should be 4,000. Oh no, that's never mind.
They yelled at both me and Nick.
Why did they yell at Nick? He had a bus.
I know. And then right now, literally right now again. And he was like, let me see your phone. I was like, you went with me. And I just walked out.
Okay, so what do you want me to write for hours spent studying, like the numbers? By ones? Okay. And then what do you want me to write for scores on the test? Do you want to do 20s? I think there's 15 dash marks.
Okay, 10.
Okay. Then I need to go ahead and plot all these points. There's 22 of them. So the person who spent 0 hours studying gets a 40. 1 hour is a 41. 2 hours is a 51. 3 hours is a 58. Then there's another 3 hours, that's a 49. There's a 4 hours, that's a 48. Yeah, there's a 448. 464. 555. 569. 558. 575. 668. 663. 693. 784. 767. 890. 876, 995, 972, 985, and 1098. Apparently this person who got a 98, they really wanted to get that 98.
I would drop. You didn't even get 100%. You studied for 8 hours and got 76 on the test. I'm genuinely concerned. Like, what did you not learn?
Maybe they weren't there the entire time and they needed to go learn it all.
Okay, but who studied for 7 hours? People who want to go. I didn't study at all.
Okay.
I did.
You really didn't?
Yeah, no, I did not. I have never studied. I studied.
Okay, so, has everyone plotted their points?
Yes.
Okay, then I'll give you a few more minutes to plot them. Really? It's not that big of a deal. It's just a mistake.
But I'm writing it.
I have whiteout if you need to borrow it. Okay. Okay. So, are these points positively correlated, negatively correlated, or no correlation? So, even though you're making fun of these people, what can you conclude? Yeah. So, the more you study, the better you do.
How many chapter tests do we have to do? Just 2? Wait, only 1? We're in chapter 2 now. Wait, what was the test that was Thursday?
That was the first test. We haven't had a test before that. The other ones have been quizzes. Because the first chapter we did was a prerequisite, so it wasn't actually our standard. Okay. Okay. So the last thing we're going to talk about is a line of best fit. What? It's the line that fits as close as possible to all the data points. Calculators can use something called regression to find this line. Okay, so a correlation coefficient is a number between -1 and +1 that tells us how well the line fits with the data. So a positive number tells us it has a positive relationship, so it goes up the further you go right. And a negative number tells us it has a negative relationship. Okay. So numbers less than 0.30 have a weak correlation. Numbers greater than 0.75 have a strong correlation, so that means they're really associated. And then numbers between 0.3 and 0.75 have a moderate correlation. So this is represented by the letter R on a calculator when you get your equation of the line. And I have the steps to getting the equation of the line below. So the steps are down here, but we'll move on. So this one tells me the table, guys, quiet down. This tells me that the table shows the numbers n in millions of tax returns that were filed through e-file from 2006 to 2013. It wants me to use the regression feature on the calculator to find a linear model for the data. And it tells me to use t equals 6 for 2006. So when I type all of these into the calculator, I'm not typing the actual year, I'm just typing the end part of the year. Okay. So I just wrote off to the side the numbers I want to do. Then on my calculator, I want to press the stat button, which is next to the left arrow. I want to edit, so I'm going to press enter. If I have numbers in my list, I want to arrow up to the list name, like L1, like how it's currently highlighted, and press my clear button, and then arrow down, and it clears the list for you. No, stat, edit. Okay. So once I've cleared those out, I want to go ahead and enter all my X values. You're not on stat plot. You go stat and then edit. Right next to the left arrow. Okay. So then once I type in my X values, I want to type in my Y values. So these are the other numbers. No. Why are you so rude? Okay. Has everyone typed in their points? Okay. So then what I want to do is I want to press second and then the mode button to go back home. Yeah.
Oh, just hit second.
Yeah. And then what I want to do is I want to press the stat button again. This time, I'm going to arrow over to the middle where it says calc. And I want to do a linear regression because I want to get the equation of a line. So I'm going to pick choice 4. And then all I need to do is just arrow down until I hit calculate. And then it gives me all these values to plug in for A, B, and then R at the very bottom to tell me how strong of a correlation it is. Okay, so if you're not getting R, what you need to do is you go second and then press 0. And it should pull you up to a catalog. And you want to scroll down until you find diagnostic on. Ooh. Diagnostic on. And then you press enter, and then go back and repeat the steps to do the... If only I had put them on the other page of your notes. Okay. So, to go get the equation of the line, did you press enter after you did diagnostic on? Okay. So I'm gonna go over to stat, go over to calc, and then I want to choose choice 4, all the way down to calculate, and now it should pull up the R value. Okay.
Oh, I forgot to click enter after clicking diagnostic whatever it is.
Okay, so A wants me to write the linear equation for the line. I'm going to do y equals. I'm going to round my A value to 2 decimal places. So it's going to be, guys, what is A rounded to 2 decimal places? 7.30, because that 7 makes the 9 round up. And then I have an x after A, because it tells me the formula right up at top. And then plus my B value, which is, and that's my answer for A. So looking at my R value, it's really close to 1. How well does this model represent the data? Are numbers close to 1 good or bad? Good. So I'm going to write it has an R value and of 0.99, so it represents it well. Regression isn't that hard. You just type it in the calculator. Okay, you can study the steps.
Look at you! Study!
Okay, so C wants me to use the model to predict the number of tax returns made through e-file in 2015. So what number should I be plugging in for X? 15. So I'm going to do Y equals 7.30 times 15 plus 29.57. What do you get? Okay, so remember this was measuring in millions. So I want to say million tax returns.